we shall see about the memory organization of PIC. So PIC, as we all know, it follows a Harvard architecture. What do you mean by Harvard architecture? Harvard architecture, it is architecture where the processor can access from two memories. You have an individual data memory and an individual program memory. So data memory is usually a RAM and a program memory is usually a read-only memory. Program memory is otherwise said to be an instruction memory or a code memory. Now, as far the PIC is concerned, PIC has data RAM as well as a program read-only memory. So it follows a Harvard architecture. So under the data RAM, here in PIC, it is said to be as a file register. So the data RAM is otherwise said to be as a file register, is divided into two sections. The first section is said to be as a special function register, and the next other section is said to be as a general purpose register. So in short, special function registers are said to be as SFR, general purpose registers are said to be as GPR. So what are special function registers? These special function registers are used to configure some specific functions. For example, in case of a PIC, we have kind of a PIC input output ports, we have timers, we have serial communication and interrupts, and we have lot of operations inbuilt on chip. And so we have as some registers which are said to be as a special function registers, where we can configure these registers, and again there are registers where the results are automatically stored. For example, when we multiply a number two 8-bit numbers, the result is automatically found in PRODL and PRODH. So two 8-bit bits will give an answer of about 16-bit. So the lower 8-bit will be saved in PRODL, whereas the higher 8 bits will be saved in PRODH. So that's why I said you all the special function registers are not meant to be configured. Some registers will hold some data automatically. So for example, there is a register called as a W register, which is equal to that of an accumulator. So whenever an operation is done, whether it's an addition or subtraction, multiplication or any kind of a logical operation, one operand will be saved in the W register. So that is also a special function register. So you will have W registers, you will have ADC registers, you have registers related with the ports. So you have some registers which are related with timers, serial communications. So these are registers which are called as a special function registers. And the next part of your file register is called as a general purpose register. So general purpose register is a location where you can access it using the addresses, and again it is said to be as a scratch pad operation. So they do not have any dedicated specific function, but it can hold some data. So that can be addressed straight away by an address. For example, move LW 0x20. So if this is an example, it means that we need to move some literal value to the W register through the memory location 0x20. So this 0x20, it's nothing but a general purpose register. So this is a diagram that has been shown here. So you have file registers for PIC 12 to the leftmost, and then to the middle PIC 16, and to the rightmost is PIC 18. So you can see how the memory size is getting increased. So there is some region which is called as SFR, and some region which is called as a general purpose. So you can see the general purpose location is would be larger than that of the special function registers, where the special function registers ranges may change from one PIC to another PIC. In case of PIC 12, it is from 00 to 07 because it's a very small memory, and in PIC 16 it's 00 to 08, whereas in PIC 18 you can see it's 0002 F7 FH hexadecimal. So these are called as a general purpose. The other half is part is called as a special function registers. So this is another diagram to show the file register of PIC 18. So you can see some range. For example, we should understand that the RAM is almost, in the case of PIC18 it is 4K, whereas the read-only memory is of about 2 MB. So the range of address also may change. For example, for a 4096 bytes or otherwise 4K memory, so you need to have around 12 bits. You'll have about 12 bits in binary. For example, 4K, it starts when you convert this into powers of 2, you'll get an answer of 2 power 2 into 2 power 10. So 10 plus 2, you'll get an answer of 12. So you need around 12 address lines to address around a 4K memory. So with 12 bits, the range of the hexadecimal value will range from 000 hexadecimal to FF hexadecimal. So this is the range where the memory size is little around 4096. Similarly, in the case of a higher processor, when the processor the size gets increased, so accordingly the range of the memory may also get changed. So again, you can see here it's divided into SFR and GPR. And again the access bank, you have something which is called as an access bank, where you have some part of a general purpose and some part of the special function register. Put together it forms around 256 bytes. Individually it's about 128 bytes. So this memory, it's called as a file register in PIC18. And similarly, this is a diagram which is showing the special function registers of PIC. So you can see you have some port pins, port registers, you have latch register, tri-state register. These are all to configure the ports. And you have some register which is called as TCON, TMR2, PR2, T1CON, TMR1L, low. All these are related with the timer, and these registers has to be configured for the timer operations. Similarly, you have some registers for the interrupts in CON, and some registers for the lookup table like table pointers, TBLRT, and some registers for the pulse width modulators, some for serial communication like TXREG, TXSTA, RCSTA. This is all status, and you have some timer related with that also. And for example, for interrupts, you have PIE, PIR1, IPR1. All these are related with the interrupts. So you have T0CON, TMR0, TMRH. So a lot of special function registers that's available in TINA. So coming to the program read-only memory. So as I said, it's a Harvard architecture. It has RAM as well as read-only memory. So you have a program read-only memory. You can see to the right you have a data memory, and to the left you have a program memory. So the data memory is accessed with 12 bits of address lines, whereas the program memory is accessed with 21 bit of program address. So with 21 bits of program address, your size of the program memory will be of around 2 MB. So that, for example, I can say it's 20. You will have about 2 power 1 into 2 power 10 into 2 power 10. So you will have about 21 bits. So 21 bits program counter is needed to access from the program memory, whereas in the case of a data memory it's around 4 KB. So 12 bit address lines is enough. And you can see the size of the data bus is 8 bits, whereas the instructions about 16 bits, which will take 2 memory locate. Thank you.